Okay, hello. Welcome to 345 Tech Talks, and today we are going to talk about data lakes. I'm here with Paul Brown, my co-conspirator in 345, and we're both at home. We're not yet in isolation. It was just a working from home day.
Yeah.
But today we're talking about data lakes. So kicking this off with the big $64,000 question, what is a data lake?
That's a really big question. A data lake's really, almost what it says on the tin is designed to store huge amounts of data. The data is, the sorts of sizes of data that we're talking about is, in the terabyte plus range. Of course, you can store whatever you want. You don't have to store terabytes and terabytes of data, but it's really, really designed for that scale of data.
So you store data from all over your business of all different types in the data lake. But how does that kind of look? Is it just, is it just like a black hole that you shovel this stuff into, or is there something a bit more about it that's?
Sort of, yeah. A black hole would sort of suggest that it goes in, never comes out again. which may be the case with some people's data lakes, but generally speaking, you should know what's gone in there and know how to get it back out again. But generally speaking, yes, it's data from, or can be data from all over your business. The data can be of lots of different types of format. It's not, you're not restricted to only storing particular formats of data, for only storing particular structures of data. So it's really designed for you to sort of hesitate to say dumping ground for data, but in a way you could almost think of it as a place where you just put the data. Let's worry about what we do with it later, but let's store and capture the valuable data that's going in the business.
And I think that's the that's part of the change in paradigm, isn't it? That if you say all data is valuable, I just don't know yet how I might be able to use this. So whether it's the logs from your applications, or whether it's customer invoices, or whether it's everyone's timesheets, or just all this data, you don't quite know what you're going to do with it, but you kind of think any of this at some point in the future, I can actually look at this, make sense of it, and extract value from it. And it's that kind of paradigm of where we used to be was that you'd filter everything out and only keep what you thought at the time was really valuable. And now people kind of realize that with kind of big data thinking, that the value is something that you realize in the future and you don't quite know what it is.
Yeah, absolutely. Data exists all over the place within an organization, and there are the sorts of data maybe that you're talking about. If you've got a document, it's likely to be in a document storage system somewhere. Logs are going to be maybe on different machines. They may be collected into a central logging repository, but that will exist somewhere else. And all of this data exists all over the place. And then it becomes very difficult to, it's very disparate, so it becomes very difficult to query. Whereas, the idea behind a data lake is actually let's collect that data into a central location, because all of that data is valuable. But generally, that's fairly static data. You've got to think about all the transient data that happens in a business. The data that's captured as part of a transaction or part of a process that you probably should be thinking about capturing. Maybe you don't at the moment. Maybe you want to capture it. You want to get some insights from it. So that transient data that also almost lives with the transaction, capture that and store it as well.
Because often the database record is the end result. But actually how you've got to that end result is something that is often just discarded into the ether.
Exactly, yeah. So the journey that transaction goes on before it's committed somewhere, or before it ends. That journey in itself can provide really good insight. So, a lot of organizations may not be thinking about capturing all of that data, all of that transient data, or they may be only capturing some of it. They might not be capturing all of it because there might not be anywhere really to put it.
So and that's the kind of the probably again one of the differences with kind of cloud versus sort of old computing, isn't it? Because previously you'd size up you'd size up a server installation, you'd have a certain amount of disks, and actually to go and get more storage to stick more data in, it's kind of you actually had to buy stuff and physically stick it in somewhere and configure things. Whereas if you're using cloud technology, it will just expand, and and you don't actually need to you don't need to provision anything to do that.
Yeah, so the almost the lost art of capacity planning, right? So so when I first started work back in the late 80s,
you don't need to give away your age.
On mainframes, there were people who were the full-time job was to capacity plan.
And some of the systems we've worked on, even much more recently, when you're talking about systems that are handling tens of millions, hundreds of millions of transactions a day, disk space fills up, and then you have archive strategies and that sort of thing. But as part of that, one of the things that when you archive usually means purging, whereas actually you don't whilst you may be purging stuff from your transactional processing systems, actually there should be a copy of it somewhere else that's on really cheap storage for later. And that's the thing, isn't it? Because databases, particularly high performance databases, are really expensive. In terms of the amount of data, the price per gigabyte or whatever, however you're pricing it, for a high performance database, price per gigabyte is expensive.
Yeah, it's very expensive.
And what you want to do is to say, actually, I'm not going to look at it that often, but I just want to keep it. And if I need to look at it, it doesn't have to be that fast. And the storage cost per gigabyte of that is tiny. It's a fraction of what it is for a high performance database.
Yeah,
and I think that's the difference in
exactly. Think about hardware like SANs. They're hugely expensive. So are you going to be storing everything and anything on your SAN? Probably not. You're only going to be storing the data that you need to run your system and to gain the amount of analytics that you need that people are asking for. If at all, even on your SAN. But it's you're absolutely right. So the idea of having somewhere where you just go crazy, store as much as you want, doesn't really exist so much, I would say, on premises, because of figuring out how much disks you need, figuring out how long is it going to take for the procurement of those disks to then go through the system for them to be provisioned to be available. So all of those things need to be considered. Hence why you would keep a fairly tight control over what data you're storing, so you could predict. Whereas with data lakes, you're not really predicting, you're just assuming that you're going to store huge amounts of data, because you don't know when you're going to need that data at some point in the future. And go back to the sort of transient data, from that's maybe captured as part of a transaction. Once you've lost it, you've lost it. So you could be capturing that data, let's say, for 6 months in the data lake, and then somebody comes along from the business and says, okay, so I've got this question. How do I find the answer? And it's like, well, if you've lost that data, then you can't. You might be able to say, well, we need to get this data now, so we need to do a project to capture the data, and then in 6 months' time, we'll be able to tell you what the answer is. which isn't necessarily very good for businesses that maybe need to react to what happens in their market and need
And
to be
this,
able to react
and it's
quickly.
kind of the way that when we talk to clients about data strategy, the first thing first thing we sort of start saying is, well, what are the questions you need answers to? And then you go and find the data that will give you those answers, and then you kind of manipulate. How do you manipulate that data to give you those answers? So it's kind of, but you always got to start with what is it you need to know from your data. And like you say, if you then sort of say, well, where's the data, and it's like,
I don't know. Yeah.
we threw it away. Like you say, then you then have to have another project to capture it, and then whereas capture it first. So here's a question then. Structured data, like data in databases, particularly ones where you purge older data from. At what point does that, how do you actually get that into your data lake? Do you sort of have a daily extract job into your data lake? Do you try and make a copy at same time as you insert it? I mean, what are the normal practices for doing that sort of thing? Or is that a kind of, and it depends?
Well, unfortunately, it does, because there's so many technologies now that you can use to feed a data lake. Years ago, there probably would have been just some sort of batch job or data movement job that would have happened to move the data from the transactional system maybe on a daily basis to your data warehouse or your analytics database. But nowadays, you've got stream processing, you've got event streaming. There's lots of different ways of being able to move data into a data lake. That quite often it really does depend. Depends on the technology stack. Depends on, is it on premises, in the cloud? So it really does.
A lot of people still got some. They might have some data in the cloud, some on premises, and the strategies you do for each of those might be different. So it's
absolutely, and also, one of the things that we often talk about is if transactional systems are on premises, well, you don't need to do your data analytics these days on premises. You could have a hybrid solution where you offload the data analytics to the cloud, take advantage of the cloud and its sort of elastic capability to scale out.
Take a copy of your data into the cloud.
Absolutely.
So that analytics isn't having an impact on your life systems. Crunch the numbers to your heart's content, because that's the sort of thing that cloud's really good at. Because a lot of the big data analytics needs a lot of compute, but for a short space of time. And if you do that in the cloud, it's you're only paying for those. You're only paying for what you use.
Yeah, and that's almost part of the problem with traditional data warehouses built on database technologies. The database server still needs to run.
Yeah.
Whereas, with data lakes, certainly the cloud based data lakes, you just pay for the storage, and then you separately pay for the analytics on almost like a per query basis. So the costs are separated. So if you store the data in the data lake but not do anything with it, yes, you're going to get storage costs, but you're not going to get any other costs associated with accessing the data and running queries over it.
And the storage costs are quite low.
I mean, I guess data lakes wouldn't, in the petabyte range, data lakes, they probably wouldn't work if the storage was expensive.
But that thing with databases, though, that a normal database, like a normal relational database, you're paying for the processing, whether you're using it or not.
Yes.
Because that processing power is always on tap because you've got a server running a database.
Yeah.
And those processes are there whether you're actually making queries or not. So moving on, so the question on everyone's lips is, I've kind of heard of a data lake, and I've heard of data warehouses, or we've got data warehouses. What's the difference between those things?
So a data lake. So the main difference is really the types of data that you store in each one. So a data lake is a place you can store structured data, but you can equally store unstructured data. Whereas a data warehouse is really designed to store highly structured data that has been pre-planned to be the data that you need for specific analytics, specific questions that you're asking. It's been pre-prepared that that's the data we need to produce a report or to produce some dashboard. And that data then ends up in a place where it's already structured in that way to be able to answer those questions. Whereas with a data lake, you haven't necessarily asked the questions of the data yet, so you just store it, and you store it in whatever raw form it arrives in, because you don't know how you're going to post-process it.
So a data warehouse, basically a data warehouse is a database that you've pre-designed to answer a particular question in a particular way.
Yeah.
And then you load it with data, and then there's the whole building cubes, which is really just getting that data into memory so you can then slice and dice it. But you've already decided this is my data set, this is how it looks, and then you load it. Whereas so
exactly, you want to store data over and above. In a data warehouse, you'd only store the data you need. Going back to the capacity planning issues before, you'd only store absolutely what you need. You wouldn't store over and above that, because you're putting that, generally speaking, in the past anyway, on relatively expensive disks. So excess data is fairly wasteful. Whereas you don't have that problem with data leaks. But then equally, you don't know how you're going to process that, how you're going to do your analytics over that data. You might have to transform the data in order to be able to do, to run some sort of analytics on it, to be able to get some data out of it. But you would decide that at the time.
Yeah, because this is because it used to be like for data warehouses, used to get ETL, which is extract, transform, load. So you extract something from the source system, you transform it into the format of the data warehouse, and then you load it into the data warehouse, ETL. Whereas in data lakes, they talk about ELT, which is extract it from the source system. L is load it into your data lake, and the T is worry about what format it's going to, kind of as an after step.
Yeah. So when you've got a requirement to produce a particular report, then at that point you look at your data lake and say, okay, so we've got the data, but it's maybe not in a format that's going to be suitable for us to be able to do those analytics on. So we transform at that point. So you would take a subset of the data in the data lake to satisfy your report, and then you do the transform at that point. So hence why you end up with ELT versus ETL. That they also there's a term for that, ELT, which I really like, which is data wrangling. I think that's such a great term. Because it's much more. Acronyms tend to be quite dry, don't they? But data wrangling, I think, is a really great expression.
Because wrangling is kind of
grappling.
It's like taming, isn't it?
Yeah, exactly. Yes.
It's like riding the bucking bronco.
Exactly, the bucking bronco of data. That's absolutely brilliant.
That's good. So I've just lost my thread. So what was good? So the other thing I was going to kind of say is that when you're talking about these petabytes of data, and when you maybe extract data, we know that in databases you kind of think of data as being one record at a time. Whereas in fact, it's not quite like that because they're all in pages and and binary on disk. But if you were to be, let's say you were sticking logging data in a data warehouse, if you were to create like, if you were to write one log entry at a time, you'd just have like billions and billions of documents in a data warehouse. But at the same time, if you make them too big, then it's going to be really hard to crunch through them. So, if you've got data like log data, would you have a file that's got like a day's transactions in it and whack that in, or?
No, not really. So you'd still, one log entry per file. If you think about modern logging these days, then it tends to be structured events.
Tends to be like a JSON document, something like that.
Like a JSON document that would have, a bunch of metadata associated with log entry, and then obviously the message associated with the log. In the old days, it was you just write a string out, and you would almost naturally put some structure to the string.
Yeah, you delimit it, or you'd have it sort of or you give it a certain number of characters for this or that or whatever.
Exactly. So it'd still be readable, but you'd start to, okay, I'm going to, every log entry is going to have the time at the beginning, and then maybe it'll have some sort of severity to it. Maybe, is it an error warning? Is it just a normal informational message? You might have like an error, a code associated with it, and so on. And so you'd start to almost naturally put some format into your strings. Now, modern logging is really based around structured events, where you actually log some form of document, which a viewer could interpret that document and print out the string and maybe give it a different color if it's depending on the severity and so on. And then use the metadata to allow you to filter, to search. So you would have things like maybe a tracking ID or tracing ID that you could then group related events together. But ultimately, what it boils down to is it's a document. And so you can store those individual documents of, thousands upon thousands of documents in Data Lake. But it's still a document.
What would the meta, because that's because I think a key thing, because with a data lake, I suppose, one of the key differences between storing something in a data lake and just whacking loads of documents into a document library is apart from the kind of the scale is that the metadata is a crucial part of a crucial piece of the puzzle, isn't it? Because it's the metadata that allows you to find the stuff later in a useful way.
Yeah, absolutely. So you could almost think of a lake as, real lakes, just loads of water. If you were to just throw data into a lake with no thought about how that data is stored in terms of, do you store it in some form of hierarchy to make it easy to find stuff? Do you give the object names for each piece of data that you put in there? Do you actually format the object name up that makes it somewhat understandable to somebody, looking at the data lake and going, actually, I can sort of roughly understand what that file is associated with. And also using, potentially even using separate metadata stores that provide a sort of like a very structured metadata view of the data in a data lake. So you could store the data in the data lake in just one big bucket, or you could maybe hierarchically store it, but actually point to it from almost a highly structured, indexed metadata store. That means that you can find your data and then find the pointer to that data where it exists in the data lake.
Yeah. So the data is a blob of binary somewhere, but it's the fact you've got an index that points to it.
Yeah.
And then you can that when you actually want to run your analytics, you go to the index and say, point me to all the data that fits these criteria.
Yeah.
Between this date and this date of this type, relating to this thing. And as long as you've categorized it correctly on the way in, then actually coming back later, you can get to that. And so.
Yeah, exactly. So there's always, if you just had a piece of data, you didn't know what it was, you just threw it in the data lake, then, if you don't know what it is going in, no one's got any chance of knowing what it is coming out again. So you're always going to have, the context that when you've got some data that you want to store in the data lake, that point in time, you have context for what that data is.
But at the point in time when you put it in, you know what it is.
Exactly.
But if you don't tell anyone else, then who's going to know? So exactly. So that's the key, really, is that at the time, when that data is live and current, you know what it is. You store it and you tell, and that allows you to tell everyone else for posterity what it is.
That's it. That's exactly it. So so you have metadata around the data that you have, and just simple things like maybe obviously date time that you captured it, maybe the data is associated with a particular system, maybe it's associated with a particular user. All of these things can be captured, maybe the machine that it was captured on, possibly what type of format is that data. Obviously, us humans, we can open up a file and go, well, that looks a bit like binary, or that's a JSON document, and maybe that's a YAML document. But it's really useful for machines to be able to say, well, the point that I store the data, I know it's a JSON document because that's what the system always produces. That's what I'm always going to store. So it's a JSON document. So storing the format of the data, and there are some standards that are happening in this space as to the sorts of standard fields or meta should be capturing associated with objects of data or blobs of data that you store in the data lake. So these are things that are worth capturing. The other things like the provenance of the data, where did it come from? Is there any sort of security classification on that data? How long should this data be stored? Regulatory requirements. Some data needs to be stored, like finance data in the UK, needs to be stored for 7 years. So there's definitely lots of really good things that you can, good metadata that you can use, to capture in your metadata store associated with a blob of data. It just makes it so much easier to be able to locate that data, particularly as it's potentially coming in from lots of different places.
Cool. So to answer our question that we started out with, what is a data lake? A data lake basically is a blob store and a metadata store.
Yes. You could say optionally a metadata store. If you were to consider that as a separate entity, it could be that you have reasonably simple requirements of a data lake. So data lakes can be hierarchical. So the way that you store objects are very much like you store in a file system. So you might be able to define your almost like your folder hierarchy and your object naming to be your metadata store. But if you want to go searching for things, then you might want the richness of a more dedicated metadata store, and certainly the cloud providers are offering services in that area. So if you're building a data lake from scratch, then it's probably a good idea to start with that in mind, is to go from the outset that we will have a separate metadata store, because you might only initially store one type of data in the data lake. Maybe it's only come from one system, but eventually over time you might expand your use of it. So starting with a pretty good metadata model.
If you're starting with one kind of data, and that was all that was ever going to happen, there wouldn't really be any point. It's the fact that you've got to have, you're missing the trick if you've only got one type of data to put in your data lake, because almost certainly everyone's got all sorts to put in there.
Yeah, absolutely.
So, well, on that note, I think we can wrap. Having discovered what a data lake is, I think we can wrap up this episode. And in the next one, we'll delve even more into the nuances and complexities of data lakes. So, thanks everyone for listening to us ramble away, and we will be with you next time. All right, bye now.